Potentiometer. The relation between the terminal voltage V, the electromotive force epsilon, the current I, and the internal resistance R of the battery was also obtained. V is equal to epsilon minus I into R. If a table voltmeter is connected across the two terminals of the battery, it will measure the potential difference between A and B, that means only the terminal voltage of the battery. If the internal resistance of the battery is zero, or while measuring voltage, the current passing through the battery is zero, then according to equation V is equal to epsilon minus I into R. V is equal to epsilon, and the terminal voltage of the battery becomes equal to its electromotive force. But the internal resistance of the battery is never equal to zero. As a result, electromotive force of the battery can only be obtained if no current passes through the battery. The condition of no current passing through the battery is known as an open circuit condition. Simple voltmeter has resistance of about 5000 to 6000 ohm. Hence, upon connecting it to a battery, some current does flow. Hence, a voltmeter measures terminal voltage and not the electromotive force. Hence, in order to measure electromotive force of a battery, such a device should be prepared so that during measurement, the current flowing through the battery is zero. Such a situation can be realized by constructing a potentiometer. Potentiometer is an arrangement by which continuously variable potential difference is obtained, and it can be measured also. This can be understood from the following description of the principle of potentiometer. The principle of potentiometer. A battery of EMF epsilon and an internal resistance R is connected in series with a resistance box R and a conducting resistor wire having a uniform cross-section. Suppose that the length of wire AB is L and its resistance per unit length is ρ, so that the total resistance of the wire is L into ρ. If the resistance in the resistance box is R, the current through the wire is according to Ohm's law, I is equal to epsilon upon R plus L into ρ plus R. If the length of the wire from A to C is L, then the difference of potential between A and C will be I into L into ρ, writing this as VL. VL is equal to I into L into ρ. Substituting for I from the equation, I is equal to epsilon upon R plus L into ρ plus R. VI is equal to epsilon into ρ upon R plus L into ρ plus R into L. The potential difference per unit length of the wire VL upon L is equal to its potential gradient. Thus, along the wire, a uniform potential gradient is established and the potential drop between any 2 points along the wire is proportional to the separation of the points. The points A and C are now like 2 terminals of an electric cell, A being positive and C being negative. By changing the location of point C, different values for the potential difference can be obtained. Let the EMFs of 2 given batteries be epsilon 1 and epsilon 2 respectively. The positive terminal of the first battery, epsilon 1, is connected to the terminal A of the potentiometer, and its negative terminal is connected to a sliding key, also called a jockey, through a sensitive galvanometer. This key is then slided on the potentiometer wire to find a point C1 such that the galvanometer shows 0 deflection. This point is called the null point, and it is clear that the potential drop from A to C1 is equal to the EMF of the first battery. Let AC1 be equal to L1. Then using equation, we get epsilon 1 is equal to epsilon into rho upon R plus L into rho plus R into L1. Now the first battery is disconnected and is replaced by the second, epsilon 2, and the corresponding null point is obtained. If C2 is the null point and AC2 is equal to L2, then epsilon 2 is equal to epsilon into rho upon R plus L into rho plus R into L2. Thus, epsilon 1 upon epsilon 2 is equal to L1 upon L2. To compare the EMFs of the 2 batteries, this equation is used. Length of a potentiometer wire is 200 centimeters. With a given battery, the null point is obtained at 80 centimeters. What will be the length at which the null point is obtained if an identical wire of 300 centimeters length were used? Neglect the internal resistance of the battery and take R is equal to 0. Solution: let the EMF of the battery which is being balanced be epsilon 1. Therefore, epsilon 1 is equal to epsilon into rho upon R plus rho into L1 plus R into L1. Now R is equal to 0 and R is equal to 0. Therefore, epsilon 1 is equal to epsilon upon L1 into L1. That is equal to epsilon upon L2 into L2. Therefore, L1 upon L1 is equal to L2 upon L2. Therefore, 80 upon 200 is equal to L2 upon 300. Therefore, L2 is equal to 80 into 300 upon 200. Therefore, L2 is equal to 120 centimeters.